We are going to see about indexing in MongoDB. Generally, those who have database knowledge before know the importance of indexing. Like relations in traditional database, indexing also plays a key role. In MongoDB, indexing holds a very high value as MongoDB is mostly used in a non-transactional environment. By default, MongoDB generates an index on the ID field of every document in a collection. Let us see indexes in MongoDB in detail. Indexes are primarily for improving the performance of your find queries, but the reverse effect is that it will reduce the performance of your insert and update operations. Without indexes, MongoDB is going to search in all the available documents in that collection. So if you have indexes, the particular field will be cached and kept separately. So the search will be performed on that field only, and it will be very faster since most of the indexes will be loaded to the memory. By default, MongoDB creates an index on the ID field and you can't delete that. This is important to be notified. There are many types of indexes. I have listed few here. The primary one is the single field index. As you can understand from the name itself, it is going to index only a particular field. And the second one is a compound index. It's going to create an index on multiple fields. The third one is a multi-key index. This is for indexing fields with array type. The fourth one is a text indexing. We have seen about this for text search. And the final one is the geospatial indexes. For indexes, it's very simple. You just need to remember these four methods. First one is a get indexes, is going to list all the indexes available in your collection. Create index or the ensure index is going to create a new index on a particular field or a group of fields. The third one is drop index or drop indexes. This is for removing the index. And the final one, which the database administrators used to do quite often, that is re-indexing or rebuilding the indexes. So to start with, we are going to see how index is going to improve your performance for a find query. We'll be using get indexes, explain method, create index or ensure index. This is the list of key topics we are going to cover for MongoDB indexing. Initially, we'll be seeing these three. We'll be seeing how to list all the indexes in a collection. Then we'll be searching without indexing, followed by we'll be searching with indexing. Then we'll be comparing the query performance in both cases. So let us start with this three first. For this demonstration, I'm going to use Mongo Booster Northwind database. Under Northwind, we have a collection by name orders, which has around 830 documents. So I'll be using that for this. The contents of orders collection is listed here. These are the list of documents present in orders collection. You can see quite a lot of fields over here. To start with, let me check the indexes under this collection orders. That's easy. db.orders.get indexes. So this method is going to list all the indexes available for this orders collection. Let me execute that. So there is only one field which is indexed, that is the ID field, which is by default is going to be indexed. So there is no additional index on this orders collection. Let me do a find again. Now I'm going to search for a customer ID, that is Vinet. This is in the top of the list. Do remember that this customer ID is not indexed. So the find query is db.orders.find. The field name is customer ID and the value is going to be minute. Let me execute this one. So we have around 5 documents matching it. In the next step, I'm going to measure the query performance of this particular query. That's very easy. Under MongoDB documentation, analyze query performance tutorial is given. So in that, in the beginning, if you can see here, there is a description about the explain method with the argument execution status. This is going to give the statistics of the performance of a query. So I'll be using the same method here on this query. So this must give us the performance details about this query. Let me see the result in JSON. The key thing we have to watch is this one. The total documents examined for this query. It's 830, which is absolutely equal to the total number of documents in the orders collection. This means that MongoDB has scanned all the documents under this collection to find a result for this query. This is a poor performance. This is not appreciable. So let me create an index on this particular field, that is customer ID. So to create index, it's very easy. Just use a create index method. db.orders.createIndex on this field customer ID. On executing this, it must create an additional index on this field customer ID. Do remember that we have an index on _ID field by default. Let me run this one. So the number of indexes after is 2, before is 1. So our index is successfully created. To cross check this, let me use the getIndexes method again. We have 2 indexes now. In table view, it will be very clear. One is on ID field, the another one is on customer ID field. So now let me do the same execution stats to see how many total documents have been scanned after indexing in JSON view. So the total documents examined in this case is 5. Do remember that we have only 5 matching documents for this particular query. The query has scanned only those 5 documents which are necessary, not the all 830 documents. So this shows us the importance of indexing. We have seen all the 3 items in this list all the indexes in a collection. We used getIndexes, then searched without indexing, and we have searched with indexing, and we have seen the performance. Now to check the default ID index and then to drop index. We'll do this two together. We know that MongoDB by default will create an index on the ID field. Let us cross check that. For that, I'm going to create a new collection, test ID index. This is the empty collection. Under that, I'm going to insert a document, a plain simple document with a single field. Now we have a document under this collection. The next step is to find the indexes created. Must be a single index on the ID field. So we have an index by default created by MongoDB on the ID field. So this proves us that MongoDB creates a default ID index on a collection. Now to the next one, to drop the index. You can't drop this ID index. Let us create an index on this name field and then drop that. Creating index syntax, you know already. That's very easy. Create index and then the field name. I hope we got 2 indexes now. Now we got 2 indexes. To drop an index, it's very easy. You just need to do the same. Instead of create index, you have to just give the drop index. So the index was previously 2, now it is 1. Let me cross check it again. We have only one single index now. Drop index worked successfully.